So Szilard is a multifaceted engineer. He's a DevOps transformation lead. He's a test coach and Safe 6.0 specialist at Efficod. He's also an assessor, trainee, facilitator, and coach in test automation and testing process improvements. He is very active across many conferences, which includes Eurostar, UCAT, DevOps conference. He comes with around 25 years of experience. He is also leading a community group which is called Finish Testing Meet Group, which is active in ISTQB working groups. We're very happy to have you with us. Over to you, Sila.
Thank you so much, Deepti. Thank you for the introduction and welcome everyone to this session. I suppose it's already pretty late for you all, so I really appreciate your time and your availability. And of course, thank you for the invitation all. Today I would like to talk about one of my new best friend topic, or the latest topic which I'm going deep into, and this is actually the agentic software development practices, how to build trust in AI agents. Right? As a quality assurance lead, I've been, how to say, being honest with you, very much afraid of what's coming with AI and all the AI agents, how this will look like in the future, and how the whole software industry will change due to that. We just saw a couple of good security examples, how complex it is, how deep knowledge and experience it requires. And now we intended to give away a lot of these to AI and actually get AI to help us. So it's more complex, and software will be and already is developed by AI a lot. So as a quality assurance lead, I've been thinking all the time, like, okay, how this will look like and what are the techniques to build trustworthy AI agents. Now, I'm not saying that, it's like if we do all these, then everything will be super. Like just as Boss said as well, the Swiss cheese concepts, these are techniques that I will talk through about today that are helping us to have more trustworthy AI agents. But before going deep into the topic, let me first quickly introduce the company where I work. So Dipti mentioned I'm a DevOps and AI transformation lead at Efficode. So this is a leading DevOps and AI company in Europe. We are focusing on software development practices, developer platforms, DevOps tooling, and AI in software development processes. And we help the customers also nowadays to transform into AI-powered, software-driven organizations, partnering with a lot of different companies, of course, all the cloud providers, but also like work process providers like Atlassian and of course Microsoft, GitHub, Azure. So I would say like everything that you need to be able to create software. Now, also this means that when we focus on AI, then we focus more on how to approach and how to take AI to help you in your software development. So not exactly how to develop AI products, but how AI could help you to develop any of the software products. So we have like 1,600 customers, and as you see, we are all over the world, or at least spreading, but already with 10 offices in Europe and also in US, and growing more than 600 professionals. All right, on myself, Dipti mentioned a couple of things already, so maybe not going there, but due to, let's say, the community work I'm doing, helping the community, working in ISTQB, where, for example, I'm working with a very good team of authors, and we are working on the DevOps, quality in DevOps syllabus. So ISTQB will soon release the new syllabus that we are working on. But also I'm in conferences and reviewer and also like building local meetup sessions. So one of this meetup session I created with a couple of friends here from Finland, and actually that brought me this Tester of the Year award this year in Finland, and then also some some awards in Sweden. But this is really much on the work I'm doing on conferences, sharing and bringing people together. I used to say that I'm collecting certificates because I believe in lifelong learning. And honestly, as a coach, you need to be always on top of what you say. So it's really important that learning. So I appreciate these conferences as well as a learning platform and the people who put your energy into it to gather more knowledge and learn more. So very well done. On top of collecting certificates, I'm also actually collecting Lego. So don't be surprised if you see things around me made of Lego, which, is just making fun, having fun here. Good, but we are here more to go into AI. So let's start actually focusing on the conversation. So Martin Woodward, the vice president of developers relations at GitHub, stated a year ago that there will be greater change in the next 5 years than the change we had in the last 40 years. Change, disruption is exponentially growing. And we have to deal with that. And probably, okay, there's another saying like, the world has never been as fast as now, and it will never be as slow as now. So the innovation is amazing and the speed of innovation is exponentially growing. But we need to catch up and we need to be able to go with this. So, for example, on the latest innovation of AI, this is a really, really big opportunity in software development, right? 60% of software teams using AI see already significant productivity gain, and 45% of the there is 45% faster software releases for teams using AI tools. So these are like studies. This is the opportunity. On the other hand, we still see that 91% of organizations say they aren't fully prepared to implement AI yet. So there's the opportunity, but the reality is that we are not there. And 85% of IT leaders say integrating AI into existing workflows is harder than expected. So, just bring in an AI platform and say that, hey, start innovation and be more efficient is really not something that will just happen from one day to the other. Sorry, just need to mute my phone. All right. So there's the big opportunity. But the reality is that we are not taking up, and I would focus really on this one, integrating AI into existing workflows. So what we see is that this kind of future of software development is really AI native. However, you're not jumping there, right? AI will not be optional. All those companies that embrace it will dominate, and those who hesitate will be left behind. But how do we do that? Typically, there is also a step-by-step model here, right? Like CMMI or TMMI, we like the maturity models because they give us a bit of a step-by-step approach. It gives us guidance on how to grow and how to move there. So in phase one, we talk about AI enhanced productivity. This is more the focus where we have AI assistants that's helping you with your personal development, with your personal activities, some of those efficiency improvements. Phase two is more like AI powered agents. It's really agents that are capable of doing things already, right? Phase one, it's an assistant. It helps humans. Phase two is already an agent, single agents that work on some dedicated activities, and they are capable of doing those activities. So they can act, they can do things. Phase 3 is when we have more of these agents and we put them into a multi-agent workflow. This means we have, for example, the value stream or our process, and based on the process, we have the agents for that workflow. They are connected in, a sequence of activities. One of the output of one agent will be the input for the next agent. So, for example, I will give examples on this. Phase 4 is more like when we have a lot of agents already, they talk to each other, and there is an AI orchestration layer which is actually deciding which agent to utilize for value delivery. So this is more like starting to be more as an autonomous AI-driven software development factory. And when we are on phase 5, this means that the whole software lifecycle, honestly, the whole company is becoming AI native. Imagine that some of the agents are now the marketing agents. When you have your new software, they take all the changes and they start the marketing campaign as well to target the users, in line with the personas of that given new feature, and generating the campaign, videos for that, new documentation, etc. So this is really like when we talk about cross-functional scaled agile teams, cross-functional teams including HR, marketing, sales, everything, we will have now the cross-functional company of agents orchestrated by other AI agents. That's the future, right? This is what we are aiming for. But how to get there? Many of the companies are really on phase 1 and moving to phase 2, a bit maybe to phase 3. But integrating AI agents into the workflows is not so simple. And this is what I want to talk about more. So I actually try to simplify the word. Sometimes I would even say I'm oversimplifying the word. So when we have an AI agent, it has an input and then there is an output. Very simple. This is almost like any process we do, right? The process has an input and it has an output. There's an activity in the middle, and that's why we run it. Now, on the input side, I say that we have the communication problem. How to communicate to the agent what we actually want? What we want the agent to create, how good looks like, what is the expectation? And think about this. In software development, we have now heavy processes, process descriptions, we have way of workings within the teams, we have agreed rules, we have mindset, we have the Scrum, Agile rules or mindset and way of working, but you also inside the team, hopefully, updating your way of working based on the retrospective and always making it better and better and better. If you have a very good cross-functional team, then you work together, you know how to do things. Now, you have to bring that knowledge to the agent. You need to be able to communicate it. When you have a newcomer in the team, you do a lot of onboarding, right? You try to get the person also, the newcomer on the same level as everyone else. How to tell to the agent what to do? That's the communication problem. On the other hand, there's the Oracle problem, especially with the agent. How good looks like? Is the output correct? It's the very same correctness problem as with the test Oracle. How do we check that the result of a test is according to the needs, is the expected result? And as we know, AI is non-deterministic. It has a lot of randomness. So how can we make sure that the AI is producing good stuff, correct, trustworthy output and information? So changing this very simplistic answer, on the input, we talk about context engineering. So how to set the agent or the multi-agents system prompt, how to make sure that they communicate. Within the agent, it's the agent orchestration, AI orchestration. It's like how the context is shared between the agents. And with agent design, we try to make sure that we have the correctness in place with the different technology, using the different technology, giving knowledge to the agent and providing examples of how good looks like. So let's deep dive into this. But before we do that, let's a little bit understand the LLMs, because that's important to understand about the challenge we have here. All right. So to be honest, large language models are just sophisticated, glorified text predictors. You can fight and say like, oh, this is not true. We have a lot of technology inside that is making sure it's trustworthy, it's robust, it's unbiased, etc., etc. It's ethical. But at the end of the day, the very core of an LLM is a predictor, right? What does it do? It is understanding tokens, words in a multidimensional space. They create a vector from every token, and this is like huge amount of data points in the vector, huge amount of different dimensions. And then it starts to put these words in some kind of closeness to each other in this multidimensional space based on the semantics and the meaning of those words. So, for example, words that mean the same thing in different languages, in one dimension, they will be very close to each other. So, for example, if we just simplify this to a two-dimensional space, then you see cat and kitten is pretty close to each other. They are not too far from dog because they are both like pets. On the other hand, they are very far away from a house. If you look into, for example, the delta between men and women in this multidimensional space, this distance and dimension and direction is very similar as king and queen. So because these are this relation is the very same between man and woman and between king and queen. So this is behind the scene, right? This is how the LLM works under the hood, and it is predicting the next word. So if I go back here, it is predicting the next word based on all these understanding of the relationships. So Michael Jordan plays the sport of, it could be baseball, basketball, golf. You see those are low percentage, but basketball is the highest. So in this case, your answer will be the answer that you get from the LLM will be basketball. The problem is when the LLM actually does not know the answer, it doesn't recognize the pattern, it doesn't have anything like that in its database because it's something new. Then what happens? It just picks one of the toppest, highest priority and randomly picks one from there. And that we call hallucination. And that is mathematically inevitable. It's not an engineering flow. This is how the LLM works. So out of this, now we expect to build trustworthy AI agents, and we expect to build an agent and orchestrated agent flow that is fulfilling all the trustworthiness aspects. So, for example, this is truthful. The extent to which the model accurately represents facts and avoids producing false or misleading information. Or safety, the ability of the model to avoid generating harmful, toxic, or malicious content. Or to resist jailbreak prompts, for example, to refrain misuse. The model and the AI agents should also be fair. The model's ability to treat different demographics or groups impartially, avoiding reinforcing stereotypes, discrimination, or bias. They also need to be robust. The robustness of the model is the model's resilience under varied or challenging conditions. By the way, this is the same as robustness in software, right? It could be noise in input, out of distribution queries, adverse error prompts. And it still needs to behave properly, reliably. Privacy. The model respects the data autonomy, avoiding leakage of private or sensitive info, handling user training data in a way that safeguards identity. And then machine ethics, the last one. The model's ability to behave in morally acceptable ways according to ethical norms and rules. So we have high level of expectations for the models, right? And this is needed for the agents. And the LLMs are produced like this. But we need to make sure that we build on top of that heavily. So how can we now build trustworthy AI agents? Oops, sorry, wrong buttons. So one of my other simplification is this model, what I built based on going through several articles of what are the elements of AI agents. Let me walk you through based on that. So first of all, I believe just like in software, we should also take a test-driven approach here as well with the agents. That means first, we need to understand how we will evaluate the outcome of the agent. And by the way, we develop agents also incrementally. So incremental agent development, evaluating its result, its correctness, understanding how it works, and based on that, changing the prompts, the guardrails, the memory, everything else in the agent. So first, take a test-driven approach. What could be the evaluation? Now, evaluation could be the agent itself. It is telling, or the LLM itself, telling how good it thinks its own output is based on the input. It could be another model that is doing the same. It could be human in the loop, right? We love to say that everything is still to be checked by a human. But be honest, when we'll have hundreds and thousands of agents working with each other, we won't have the humans to check that, right? So evaluation is important. One more evaluation type is, because we are talking about software development, it's our DevOps safety net. So it's really the DevOps cycle. All our unit tests, all our security vulnerability scanners, for example, then the OWASP 10 dynamic security testing, everything will be there for us. So if you have a good DevOps pipeline with good level of testing in it, you have high chances that your AI agents, if they produce something not correct, you capture them as well. And honestly, if you have the telemetry and the observability, as you need to have with DevOps, in production, you understand how your product works. Again, you can let the agent do something, just make sure that you have the feedback cycle really back to the agent. So even the agent can update itself based on the output of the whole production cycle. Now, going deeply into this one, so we discussed a little bit about LLMs, but how do you know which LLM to select? Large language models, we have a lot of them. So if you work, for example, with AWS, Amazon Web Services, then you will probably use Bedrock to deploy an LLM, use an LLM through an API, and you can select from hundreds or even thousands of different LLMs, OpenAI and others as well. You might be able to use some own LLMs. I can run a large language model on my laptop. I have anything LLM as a framework, then I can download Olama, for example, and run it on my laptop. Understanding what the LLM can do is based on the model card. So always when you see these systems, check the model card. With Microsoft Azure Foundry, you have the very same. You can select the LLMs. Google Vertex, you can select the LLMs. So many times, and Hugging Face, and we can go out to these frameworks that provide you the different the choices of selecting an LLM. The model card is showing you different aspects of the characteristics of the model so you can compare them. You can decide which one is good for you. By the way, the price is also important, right? How much will it cost you to have a query based on tokens, number of tokens, or etc. other aspects. The next thing is to make sure that you have a proper prompt, which is in this case usually your system prompt, right? So the prompt on one hand, which is driving the definition of the agent, what the agent does, it is, for example, with Microsoft Copilot, it is called the instructions, right? Many times you have an agent and there's a set of bulleted lists of how the agent should behave. That's its instruction. Of course, the agent also gets a prompt from the end user or the other agent when they talk to each other, when they work to with each other. So if you think of GitHub Copilot, the developer is chatting with a developer agent, for example, in agentic mode where the agent can change the code. But the prompt is coming partly from the developer and from different instruction files in the GitHub. And of course, there's a system prompt within the agent as well. Now, creating good prompts is so-called prompt engineering, right? And we are nowadays talking about context engineering. The idea is to make sure you communicate as good as possible and see again communication here. Now, remember one thing. If you talk about human to human communication, communication is done by the listener. So it's the listener who actually does the communication, because if they misunderstood what was told, then communication did not happen, or it happened in a different way. Now with the agent as well, we need to make sure that the agent understands what we want. So just throwing in some simple text like "do me a super code" will not work. So understand the need for prompt engineering. Now moving forward, whatever knowledge your LLM has, it does not know your company or your technology, your domain, the language you use there. So for that, you want to bring in internal knowledge. You can bring this through search, simple search, or semantic search, but you bring this in typically through a vector database with the so-called retrieval augmented generation, which is actually bringing in the language of your own company into the discussion. So for example, when you have proper terminology, it brings those keywords into your discussion. Moving on, the agents also use memory. Different types of memory. Some memory is to remember within the session what to do. So for example, storing like variables. But the agent can also improve itself. And that's why I said evaluation is updating memory or updating the memory based on that. Because the agent might say like, I tried this thing and it didn't work, so I should do it different way. It can store it in the memory. If you check your Copilot settings or your ChatGPT settings on the client side, you will see as well that it stores information about you. It stores some level of memory and saying like, you are a person doing this, working there, interested in these, likes answers in this way. Now, when we have memory in an agent, you need to remember how that is used. For example, if between the sessions of the agent, between work sessions, the memory might actually interfere. It might remember something from the previous session. So make sure, again, that you engineer the memory, the usage of the memory, and understand that to be a trustworthy AI agent. One more is the guardrail. For example, we said we need to make sure that the LLMs or the agents are safe. We should not, for example, be able to hijack them and get data that they shouldn't provide us. So, for example, in a software development agent, we still should not be able to get customer information from production data through the agents that are working in software development. And guardrails are helping us with that. Input guardrail, so you cannot even give instructions like that, but also output guardrail, even if the LLM would answer those, because it has access to some information, it should not give the feedback to you. So there's an output guardrail as well. And last but not least, actually one of the most important thing to make an agent capable of doing things is giving it tools. Tools like simple search or accessing the web, but also through the so-called MCP servers, Model Context Protocol, really giving like an API to a large language model that it can interfere with. It can, for example, read databases, but it can write database. It can create a Jira ticket for you through the Atlassian or Jira MCP. It can talk with hundreds and thousands of different things because many of the companies already are developing MCP servers. Security of the MCP server is still a big question. Making sure that the agent has access only to data that it should have access, or for example, to the access that the user of the agent has data. So only have data that the user have access to. So for example, as Boss mentioned, you should not be able to get money from someone else's account because of a badly written MCP. But what it gives to agent, it gives the autonomy. It gives the possibility to, do things, the autonomy aspect. So all of these, and as technology grows, more and more and more capabilities are actually helping you to build trustworthy AI agents. This is really the engineering of an agent. But let's look out as well, like how do we build now this future of workflows? So it's not enough to have one well-designed agent, right? We want to have trustworthy AI agent workflows. So giving you an example how this could look like, it could be a very simple software development workflow here. We have the different agents mimicking the current software development. And to be honest, one of my dreams is, and maybe this is already done, that we just feed all our process information and all our way of working description and all our job profiles into a holistic agent, and then it starts generating these agents. Well, will we lose our jobs? Let's see, that's a different question, but I believe then it helps us to own these agents and make them better, learn together, and improve the software development process. So what you see here is the different agents. And for example, when you have an idea, the product owner agent takes that, takes your idea, start improving it, adding expectations, for example, non-functional requirements, GDPR related information, etc., that is needed in that given context. Oh, by the way, we have the DPO agent, the data protection officer agent here, which is concretely checking for security and GDPR related requirements. So now the idea is augmented, extended with company specific, domain specific requirements. Now, those requirements, there's always a human in the loop in this example. So, those are, for example, in Jira. These agents work in Jira and they just augment the ticket. Then you can read it, you say this is good enough, and only then you move them to the next Kanban board, which is actually triggering the next agent to work on it. So the requirements are now there. So it goes to two new agents, the software architect agent and the test architect agent. Test architect agent starts improving on the acceptance criterias, making sure we have a test-driven approach. But it also discusses with the architect what to test and actually giving also information to the software architect agent. Software architect agent creates implementation specification, test architect agent creates test design. And then next agents like software developer agent takes the specification, starts the implementation. And the test developer agent takes the test design and start implementing, for example, robot test cases here. And of course, now we run these against each other. That's the evaluation cycle. And when we see that, for example, the new tests have passed, by the way, reviewed by humans, and the new code has passed, reviewed by humans within the pull request, right? It's on a branch. Then you might say, okay, let's merge this pull request. And with that, we initiate the deployment part of the pipeline. So this is a very high level view. But to have this in place, to be able to have those agents, you need an AI agent orchestration platform. And that will add governance. Because think about that. You govern the people in teams. You govern them by fast cycles. You govern like feedback cycles. You govern them by mandatory processes, making the process unavoidable by definition of ready, definition of done, by CI/CD pipeline, by the team giving feedback on the element. I don't understand the requirements yet. Please explain me more. All these needs to happen with the AI agents as well, but this needs to happen on a platform. So the agent logic is in the middle, but then we need this platform which is orchestrating the agents, making sure that, for example, they can access only information that they should and they cannot access information that they shouldn't. So there's a security and governance part. Governance, you need to have audit trail. You need to be able to show what happened and why that thing happened. And that's through, for example, telemetry observability, but also recording every transaction of the agent. With this input, with this prompt, with this knowledge search, this output came, and then this was the outcome. Record that as a log file. So if there's a problem, if you cause something, you can come back and see what caused that issue. Tool abstraction layer, you might also need it. So again, MCP, data layer, AI layer, management layer is all needed. You need to be, for example, able to change the AI itself. So when ChatGPT comes up with a new LLM, now we have 5.1, just came out a few days ago, your system should still be able to work. You need to have LLM lifecycle management in place. You have to be able to test the new LLM with your agents. You have to be able to see how it behaves. If needed, you need to be able to update your agents. So you need a test environment for your agents. And then you need to be able to deploy your agents into the production line, which is your development factory. So you need this platform, and this is quite of a heavy work to build this. More and more companies are focusing on this. Just I think again, a week ago, maybe, Microsoft came out with, and I will not remember the name of that, but a new terminology, a new kind of dashboard view to control everything. It's together with Microsoft Fabric and the Foundry and with the Copilot Studio and all around that, it's a governance layer. So more and more of this will come, and the more and more of the companies will provide this level of orchestration layer around the agents as well. So I went through actually these several agents. I don't think I need to repeat them, but we have a slide again, like what the product owner agent would look like. So as discussed, ensuring the user stories are well structured and actionable. Already now many times when I want to create a user story, I created an assistant for myself, which is asking me questions, and at the end doesn't do anything else, just summarizing what I said, but in a very well structured format. So there's, for example, a feature description, there's a good name for that feature or story, there's acceptance criteria, there's a benefit hypothesis, there are risks, etc., and there are some dependencies as well. And the agent is asking me for those. So again, this could be something built in your software development, augmenting that. Data protection officer ensures compliance and best practices are followed. So looking into the idea and the requirements and augmenting it with security considerations. Test architect agent, creating new Jira issues for acceptance criteria based, it's like you test new user stories. So updating on those and having the slides. So roughly we went through these and you've seen that you can create your own agents based on your software development. And I have two more slides for the summary, and then we go for the questions and answers. So when we talk about the elements of designing trustworthy agents, if you need to remember one slide from this talk, this is the one. The communication, how you handle that, what the AI agent shall do, so the process description, information sources, take them and translate them to system prompts. Remembering the context, how you generate and handle that, context engineering, instructions, memory. Guardrails, how to make sure that you have the proper guardrails properly defined. But on the Oracle side as well, understanding the models, their data, do fine tuning if needed, but rather use retrieval augmented generation to bring in information or give model context protocol and search and other tools to the agent to access information or actually to be autonomous. And remember the feedback loops, evaluation models, human in the loop, but in software development, it's your whole DevOps pipeline. All this is built on the AI orchestration platform. So you need that to develop this. And that actually gives us to the last question. So now, if we know all of this, what is really stopping AI adoption? Typically, it's not the tech, it's still the fears. Fearing about job displacement, security and compliancy, ownership and control and quality. But I think agents will empower us, not replace us. We will work with multiple agents and helping us to have high delivery work and high quality work. Compliance can be built in through the orchestration. Ownership and control is fully there. Again, governance needs to be in place, but the orchestration layer gives you that. And then the quality, the AI produces high quality. So we need to understand how to build the AI agents, and we also need to use the CI/CD processes for that. But I would say this is really given to us. So with that, thank you very much for your listening and being with me. And if we still have time, I would be happy to have questions.
Thank you, Szilard. Thank you for having so many things detailedly laid out for us. Um, Anybody from the audience who has any question, I think we can take one.
So thank you so much, Szilard. This was one of the most wonderful learning session that we had, and an extremely detailed one. One quick question, basically with reference to the slide where you showed just two slide back. Can you go back there?
Uh, yes, which one? Sorry.
Sorry, this one. Right.
Yes.
So this is what we design in the entire process, and this is what is the trustworthy AI agents you explained brilliantly. Now, can you just give us one small or like one of the biggest challenges that somebody would face when they basically are trying to design something like this, in your opinion?
Okay, so what's the challenge? First of who do you have another 1 hour or two, or just a minute?
No, no. So, in short, in
In
summary,
short,
that
in short.
I miss telling that. Yeah.
Okay, I would say nothing new here. What I'm always seeing with engineers is they want to jump on solutioning. I want to describe how the solution should work. I always say, take the design thinking aspects, understand the problem we try to solve. If you don't understand the problem well enough, you will not be able to solve it. And with the AI agents, very much the same. What is the problem the AI agent is solving? How do you know it's being solved? Because that will be part of your feedback loop. That will be how you evaluate it, and that is again this kind of test driven methodology. But if we don't understand our own process, how the thing should be done, then it will be extremely hard to create an agent that works well.
Well said.
But on the other hand, we will get a lot of manufactured agents, right, from
Hmm.
the companies like with GitHub Copilot and all
Yeah.
those kind of things, and thousands of agents that will say that I'm this good and that good and I'm creating secure code, etc., etc. You need to see them, how they work. You need to understand why they are so good. What's the magic inside to be able to, trust those agents. I'm a
Nice.
tester. I don't trust anything which I did not break before.
Yeah. Great. Thank you so much, Szilard. It
Thank you.
was amazing session. Thanks a lot.
Thank you so much for inviting me and really appreciate the possibility. Have a good learning for everyone. Thank you.
Siddharth, thank you,
Yeah.
Siddharth.
Thank you.
Thank you, Szilard. Thank you for all of those annotations and the comparisons. We really had a good topic coverage. Thank you for being with us. We really appreciate you joining.
Thanks a lot. Have a brilliant rest of the day. Bye bye.
Thank you.